Welcome back, everybody, for another deep dive. This time, we're going to be looking at a paper that has really had a huge impact on machine learning.
It
And
has.
this is Attention is All You Need. This is the paper that introduced the transformer model.
That's right.
So before we jump into the transformer, I think maybe it would be good to take a step back and kind of set the stage. What was the state of things before this paper came out?
Well, before the transformer came out, the main approach for processing language was to use recurrent neural networks.
Right.
These RNNs were, pretty good at a lot of tasks, but they had some limitations. One big one was that they processed text sequentially,
Oh.
one word at a time.
So like if I'm reading a book
Right.
and I can only read one word at a time.
Yeah, exactly.
And I have to constantly flip back to remember what the previous word was.
That's right.
It's not a very efficient way to read a book, right?
No. And that was the problem with RNNs. They were slow, and they had trouble with long sentences because they had to keep track of all the previous words.
So if you have a really long, complex sentence,
Right.
an RNN is going to have a tough time figuring out what's going on.
Exactly. And that's where the transformer comes in.
Okay, so the authors of this paper, they decided to kind of throw out the rule book and try a completely different approach.
They did.
They said, what if we process the entire sentence at once?
That's right.
Instead of one word at a time.
Right.
And that was the big idea behind self-attention.
Right.
So how does that work? How do you look at an entire sentence simultaneously?
So you can think of self-attention as like a way for the model to figure out which words are most important in a sentence.
Okay.
And it does this by comparing every word to every other word.
Okay.
And then based on that comparison, it gives each word a score. And that score tells us how much attention that word should pay to the other words.
So if we have a sentence like, the cat sat on the mat,
Right.
the word cat is probably going to pay a lot of attention to the words sat and mat.
Exactly.
Because those words are related. But it's not going to pay much attention to the word the.
Right.
Because the is just a kind of a filler word.
Exactly.
It doesn't really tell us much about the cat.
And that's the beauty of self-attention.
Mm-hmm.
It allows the model to focus on the important parts of the sentence and ignore the irrelevant parts.
And it's doing all of this in parallel.
That's right.
It's not going through the sentence one word at a time, so it's much faster.
Much faster, much more efficient.
Okay, so self-attention is the kind of the heart of the transformer model,
Yes, you can say that.
but it's not the whole story.
It's not.
Right. The transformer is actually a pretty complex architecture. It's got like an encoder and a decoder and all these different layers.
Yeah, so it's like a well-oiled machine
Okay.
where each part has its own specific job to do.
So can you give us a kind of a high-level overview of how the transformer works?
Sure. So the transformer takes in a sentence as input,
Okay.
and then it passes that sentence through the encoder. And the encoder's job is to basically analyze the sentence and figure out what it means.
Sure.
And it does this by using self-attention
Mm-hmm.
to figure out which words are important and how they're related to each other.
So the encoder is kind of like reading the sentence and taking notes.
Exactly.
Like highlighting the important parts.
Right.
Okay, so once the encoder has done its job,
Right.
what happens next?
Well, then the output of the encoder gets passed to the decoder.
Okay.
And the decoder's job is to generate a new sentence based on the information that it got from the encoder.
Okay.
So, for example, if we're doing machine translation,
Uh-huh.
the encoder might analyze a sentence in English,
Right.
and then the decoder would generate a translation of that sentence in French.
But how does the decoder know what order to put the words in?
That's a good question.
Mm-hmm.
So the transformer uses something called positional encoding.
Okay.
And this basically adds information about the position of each word in the sentence.
Okay, so it's like giving each word a little tag that says, I'm the first word, I'm the second word, I'm the third word.
Exactly. And that way, the model knows the order of the words, even though it's processing them all at once.
So that's how the transformer is able to kind of have its cake and eat it too.
Right.
It can process the entire sentence in parallel,
Right.
but it doesn't lose track of the order of the words.
Exactly.
Okay, so we've talked about the encoder, the decoder, self-attention, and positional encoding. Is there anything else we should know about the basic architecture of the transformer?
Well, one more thing that's important to mention is multi-head attention.
Okay, so multi-head attention, what is that?
So it's basically a way of doing self-attention multiple times
Okay.
in parallel.
So it's like having a team of experts
Right.
all looking at the same sentence,
Right.
but from different perspectives.
Exactly. And each of these experts, or heads as they're called,
Uh-huh.
can focus on different aspects of the sentence.
So one head might be looking for the subject of the sentence.
Right.
Another head might be looking for the verb. Another head might be looking for the object. And
Exactly.
by combining the information from all of these heads,
Right?
the model gets a much richer understanding of the sentence.
That's right. It's like getting multiple opinions on something,
Yeah.
to get a more well-rounded view.
Okay, so that's multi-head attention. And all of these things together, the encoder, decoder, self-attention, positional encoding, multi-head attention.
Right.
These are the core building blocks of the transformer model.
That's right.
It's a pretty complex model, but I think we've done a pretty good job of breaking it down so far.
I think so, too.
So now that we have a better understanding of how the transformer model works,
Right.
I'm really curious to know, did it actually work?
Oh, it worked incredibly well.
Like, how well are we talking?
It really blew past everything that came before it, especially when it came to machine translation.
Oh, wow.
They used a metric called the BLEU score
Hmm.
to measure how accurate and fluent the translations were. And the transformer just, it just blew everything else out of the water.
So not only is it faster
Right.
and more efficient,
Uh-huh.
it's also producing better results.
Way better.
Wow. That's pretty impressive.
And the exciting thing is it's not limited to just machine translation.
Right, because I was thinking,
Yeah.
if it's so good at understanding relationships between words,
Mm-hmm.
it seems like it could be applied to a whole bunch of other language tasks.
That's right.
Right.
Researchers have used it for things like summarizing text, answering questions,
Oh, wow.
even generating different kinds of creative text formats, like poetry and code.
That's incredible. So this one model can do all of that.
It's pretty amazing, right? And all of this is because they decided to ditch the sequential processing.
Right.
They questioned that fundamental assumption that you had to go one word at a time.
Yeah. It's amazing how much progress can be made when you're willing to challenge those long-held assumptions.
It really is.
So speaking of assumptions, I have to admit, I was making one myself when I was reading the paper.
Oh, what's that?
I assumed that by ditching the sequential processing,
Uh-huh.
the transformer would also be less computationally expensive.
Yeah,
Like it would require less computing power.
I can see why you might think that,
Yeah,
but it's a
that's
little more complicated than that. For very short sequences, self-attention can actually be more computationally expensive.
Really?
Yeah.
So there's a trade-off.
There is, but here's the thing.
Okay.
Most real-world language tasks
Mm-hmm.
involve much longer sequences,
Right.
like sentences, paragraphs, whole documents.
Right.
And for those longer sequences, the transformer's ability to process everything in parallel
Uh-huh.
gives it a huge advantage.
Right. Yeah.
So in the long run, it ends up being much more efficient.
So it's like a short-term cost for a
Right.
long-term gain.
Exactly.
That makes sense. So aside from speed and efficiency, were there any other benefits to ditching the sequential approach? Did it change how we understand what's happening inside these models?
Oh, absolutely. One of the big advantages of the transformer is its interpretability.
Okay.
With RNNs, it was often really hard to tell why the model was making the decisions it was making.
Right. It was kind of a black box.
Yeah, total black box.
Right.
But with the transformer, because we can see the attention weights,
Mhm.
we can actually see which parts of the input the model is focusing on when it's making a prediction.
You can see what the model is paying attention to.
Literally.
Whoa, that's incredible.
It is, and it's given us amazing insights into how these models understand language.
Like what kind of insights?
Well, for example, we've learned that some attention heads seem to focus on the grammatical relationships between words,
Mhm.
while others seem to be more focused on the meaning and the context.
It's like we're starting to understand how the machine is thinking.
Exactly.
That's amazing.
Mhm.
So going back to the paper for a moment, they also talk about some of the reasons why they chose self-attention over other approaches.
Right.
Then they mention computational complexity, which we already touched on, but they also talk about parallelizability and path length.
Yeah.
Can you explain what those are and why they matter?
Sure. So, parallelizability basically means how easily something can be done in parallel.
Okay.
And as we've discussed, the transformer is highly parallelizable because it can process all the words in a sentence at the same time. That's one of the things that makes it so fast and efficient.
Gotcha. And what about path length? What is that?
Path length is essentially a measure of how easily information can flow between different parts of the model.
Okay.
Imagine a communication network.
Uh-huh.
The shorter the path between 2 points, the faster and more efficient the communication.
Makes sense.
And with self-attention, every word in a sentence has a direct connection to every other word.
So it's like everyone's in the same room
Exactly.
and they can all talk to each other directly.
That's right. And this short path length is one of the reasons why the transformer is so good at capturing long-range dependencies in text.
So the information doesn't have to travel as far, and it can get where it needs to go much faster.
Exactly.
That's pretty cool. So they didn't just come up with this idea out of thin air, right?
Yeah.
They actually did a lot of experimentation
It did.
to figure out how to make the transformer work as well as possible.
They really put it through its paces.
What were some of the things they tinkered with?
Well, one thing they experimented with was the number of attention heads.
Right, because we were talking about multi-head attention.
Right, gang.
So how many heads is the right number of heads?
Well, that's what they were trying to figure out.
Okay.
And it turns out that adding more heads isn't always better.
Really? I would have thought more attention is always good.
It seems counterintuitive,
Yeah.
but there's a sweet spot.
Uh-huh.
At some point, you're just adding complexity without any real benefit.
That makes sense.
They also experimented with the size of what's called the attention key.
Okay, remind me what the attention key is again.
It's basically how much information each word is using to query the other words. Like how detailed of a question it's asking.
So it's like, if you're looking for a book in the library
Right.
and you have a really vague description,
Uh-huh.
you're probably not going to find the right book.
Exactly.
But if you have a really specific description,
Right.
you're much more likely to find it.
That's right.
So the attention key is like that level of detail
Uh-huh.
in the question that each word is asking.
It is. And they found that if you reduce the key size too much,
Uh-huh.
the model actually performs worse.
Makes sense. You need a certain level of detail to understand the relationships between words.
Exactly.
So they were really thorough in their experimentation.
There were. And they also wanted to see how well the transformer could generalize to other tasks besides machine translation.
Okay, so what did they try?
Well, one thing they tried was something called constituency parsing.
Constituency parsing.
Yeah.
What is that?
It's basically a way of analyzing the grammatical structure of a sentence,
Okay.
like breaking it down into its component parts.
So like diagramming sentences.
Exactly, but on a much more sophisticated level.
Okay.
And this has traditionally been a really hard task for machine learning models
Why is that?
because it requires understanding not just the order of the words,
Right.
but also the hierarchical relationships between them.
So like which words go together to form phrases?
Exactly.
And which phrases go together to form clauses?
Right.
And how it all fits together.
That's right.
So how did the transformer do on this constituency parsing task?
Remarkably well.
Really?
Yeah, even without any specific modifications, it was able to achieve state-of-the-art results.
Wow.
It's really a testament to the flexibility and power of the transformer architecture.
So we've got speed, efficiency, accuracy, interpretability, and now adaptability.
Yeah,
It's starting to sound like the perfect language model.
it's definitely a game changer.
But I know there's always room for improvement in AI.
Of course.
So were there any limitations or challenges that the authors identified?
Well, one of the main challenges is scaling up to even longer sequences of text. The transformer works well on sentences and paragraphs,
Right.
but what about entire documents or books or massive data sets?
Yeah, because the more text you have, the more computationally expensive it becomes, right?
That's right.
So how do you overcome that challenge?
Well, there are a few different approaches being explored.
Oh.
One is called local attention.
Okay.
And this is where the model only pays attention to a small window of words around the current word.
So instead of looking at the entire sentence, it's
Yeah.
just looking at a little chunk at a time.
Exactly. And that can significantly reduce the computational cost.
That makes sense.
There are also other approaches like hierarchical attention,
Okay.
where the model processes text at multiple levels of granularity.
So like words, then sentences, then paragraphs.
Exactly.
Okay, so scaling up to longer sequences is one challenge. What other areas for future research did the authors highlight?
Another big one is making text generation less sequential. Right now, most language models generate text one word at a time,
Right.
which can sound a bit robotic and unnatural.
It's not how humans write.
Exactly.
Right. We don't just think of one word at a time.
We don't. We think in chunks, we think in phrases,
Right.
and we often revise and edit as we go.
So the goal is to create AI that can write more like a human.
That's right, more fluidly and with more natural variation.
I imagine that's a pretty tough challenge.
It is, but it's an active area of research.
Yeah.
And there are some really exciting new approaches being explored.
Like what?
Well, One approach is to train models to generate groups of words or even whole phrases at once.
Instead of just one word at a time.
Right?
That's fascinating. It sounds like the future of attention-based language models is full of possibilities.
It really is. And it's all thanks to the groundwork laid by this "Attention is All You Need" paper.
That's amazing. It's really changed the landscape of NLP.
It has.
Okay, so we've covered the technical marvels of the transformer,
Uh-huh.
its remarkable achievements,
Right.
and the broader implications of attention-based models.
Yeah.
Is there anything else from the paper that we should touch on before we wrap up this deep dive? It's crazy to think that just a few years ago, the transformer didn't even exist.
I know, right?
And now it's like everywhere.
It's become so fundamental.
Yeah, like how did we even do NLP before the transformer?
It really has changed the game.
And it's a great reminder that sometimes the biggest breakthroughs come from just questioning the assumptions that everyone else is making.
Yeah, like thinking outside the box.
Exactly, and saying like, what if we just try it a completely different way?
Like, what if we don't have to process it sequentially?
Yeah, and look what happened.
Right.
This incredible new model was born.
Exactly.
So we've talked about machine translation and text summarization and question answering.
Huh?
What are some of the other areas where the transformer is having an impact?
Oh, it's being used all over the place. Sentiment analysis,
Okay.
like figuring out if a piece of text is positive or negative. Speech recognition, converting spoken words into text.
Wow.
And even in fields you might not expect, like drug discovery.
Really?
Yeah, where it's helping scientists analyze all sorts of data.
That's amazing.
It's really become a powerful tool.
Yeah, it seems like attention is this secret ingredient that's making AI smarter in so many different areas.
It's really a game changer.
And we're still just scratching the surface.
Right. There's still so much we don't know.
Yeah, like how to optimize it
Yeah,
and how to apply it to even more challenging problems.
exactly.
So, to all our listeners out there, stay curious.
Yes.
Keep learning, keep asking questions.
Keep experimenting.
Yeah, the world of AI is constantly evolving.
It is.
There's always something new to discover.
Always.
You know, I want to go back to something you said earlier about the philosophical implications of this work.
Oh, yeah.
Because you said that the success of the transformer kind of challenges our assumptions about how machines learn and how intelligence works.
It does make you think.
If a machine can understand language so well simply by paying attention,
Uh-huh.
does that mean that attention is a more fundamental aspect of intelligence than we realized?
I mean, it's a really interesting question.
Yeah,
We don't have all the answers yet,
right.
but it definitely raises some profound questions about what it means to be intelligent.
Yeah, and it makes you wonder, like, how did we decide what to pay attention to as humans?
Right.
What makes something worthy of our attention?
What makes something stand out from the noise?
Exactly.
It's fascinating.
Yeah, can we even learn from these AI models to improve our own focus and our own understanding?
It's possible.
Yeah, so as we wrap up this deep dive into attention is all you need,
Right.
I want to leave our listeners with this challenge.
Okay.
Pay attention to what captures your attention.
I like that.
Why does it grab you? What makes it stand out?
Yeah. What makes it special?
You might be surprised by what you discover
Absolutely.
about yourself and the world around you.
And remember, stay curious.